Here, we continue with this example. Example 3. You see a rocket launched from the ground. It moves upwards with a velocity of 75 meters per second. When it reached a 40 meters from the ground, engine failed. Something happened. Determine the maximum height of SB. Maximum height when it reached a point B. Reached by rocket and its speed just before it hit the ground. So this rocket is launched 75 meters per second. At the distance after it traveled 40 meters, engine failed. Then it reached a point B. Engine failed. Velocity continue to what? What happened to velocity? Slow down, right? Slow down become, when reach B, what is the velocity? 0. When it's 0, what happened to the rocket? Flip down. Then you need to find velocity before it hit ground. Okay. So you need to find the SB and the speed before here. Means at point C. The important, you label your location and what happened at a certain time or distance. That is the boundary condition that you need to aware of. Okay, by the way, this question is inside the canvas, inside the tutorial question. So before you come to class, it's good you download the tutorial question or tablets or print it out if you're lazy, copy this. Okay. All right. So this kind of question, it can be changed to kids just throwing a rocks or candy up there. Then the question will ask you what happened when, or the ice cream dropped from the cone. What is the velocity when it reached the floor? Something like that. Okay. Important that it's understand. Okay, what are the steps you need to do? Okay. While in motion, rocket is subject to a constant downward acceleration. When it go down, while in motion, rocket is subject to a constant downward acceleration of 9.81. Means gravity always pull the things from the ground O point here. Once it start to shoot up, velocity, there is acceleration, constant acceleration acting on the object. Ignore air resistance for this moment. So coordinate system, we will go up positive. Go up positive from here to here. We break the motion into two big family or two time frame. One is go up, one is go down. Don't think as one package. And this one, it have a few interest point, means target point. O to A, one incident. A to B, one incident. B to C, one incident. Don't see it as a whole thing. Because it tell you something happened somewhere. So you look at that particular time, what happened, what particular at the time. Okay. So go up positive, maximum height. As maximum height is from O to B. And this one, it tell you already, constant acceleration. So you can use the 3 Newton equation here, which is the gravitational force. Okay, so VA positive go up at t equal to 0 second. T equal to 0 second. So at maximum height, your velocity 0. These are the information you have. Or this information actually is a hidden information or logic thinking, although it's not mentioned here. So when you come to dynamics, we expect you have a higher intelligence already. So we assume you know all these assumptions. You need to think how the object behave at a certain condition. Okay, so for the entire motion, the question already mentioned, your acceleration is minus 9.81. Why minus? Go downwards, but your coordinate system go up is positive. Again, these are information we have, and then when you solve this one, don't see O to C as one motion, as one action. You need to break into O to B, one trip, one set of solution. Then when you reach B, there's another solution to solve B to C. Don't lump the whole thing together. Okay, that is the trick lah. Then negative, why the negative here? Because later when we solve this part, you ask, sir, why suddenly my acceleration, why my A become positive already? Because we set different solution for that later. So we solve for O to B first. Okay, what equation to use? So throughout these three equations, it asks you what? Height. Height is what? Displacement, position. So go and find equation that have S inside there. First one don't have. First one only have velocity and time and acceleration. So go and look into this. S equal to T and T. This one T and T. So basically, this one we don't use it at the moment because actually you can use these two lah if you want. These two works. But this example we use the third one. We just pick one to solve. So V square equal to VO plus AC delta S. Okay, so we continue to use. We look at from here to here, right? Here to here is nothing to solve, right? What you want to find from here to here. Want to find here to here how far it travel. Because here to here, 40 meter. We no longer need to solve O to A. We want to solve from A to B. So change equation a little bit. We are interested to see final velocity at B. So we write VB square. VO2, O is the previous velocity, which is A and not O. It's not O. Don't use O. Change this one to A because you are looking at here to here. Don't have careless mistakes here. You need to modify a little bit. Plus A to AC, S final location is B, previous location is A, not O. Okay. So if you accidentally use the wrong notation, this one, if you see from O to B, this one O, then different substitution already lah, different value. Okay, VB we know 0. 0 square, you still get 0. VA, what is VA? 75. Again, sometimes the question do not mention this one in the question. It will just say you that if it launch in the constant velocity, then it suddenly fail. It means it still move in this velocity at that point, that incident point. Okay, so this one 75. Acceleration is what? Positive, negative? Negative, because we assume from O to B, positive direction go up. Okay. Then, why? Why I say negative? Where is the gravitational force? Go down, acceleration, gravitational force go down, right? So this is vector of your gravitational force, pull you down. But your positive axis is where? Go up. So these two are opposite direction. So If you put positive, means gravity pull up. So negative here. He already tell you in the question. Gravity pull down. So SB minus ASA, you know, you start from 40, not start from 0. This is 40, then there's a value here. So you solve, you get 300 something. Yeah. Velocity, just before it hit the ground, we know the SB. SB is the total height it reached. Yeah. SB is a location. It's a location. Don't confuse with, actually it's a coordinate system. Don't confuse with the total length. Don't confuse with that. So before it hit the ground, again use the same equation. In this case, in this case, VB 0. In this case, we take SC minus SB. In this case, acceleration also VB. Hold on. VB. Yeah. Okay, if you substitute negative here, if you substitute positive here, you will get negative value, right? If you substitute VC equal to positive, this one you get negative. If you substitute negative, you get positive value. It should be positive. So actually something wrong here. Typo error. Okay, typo error. From here, from this point to here, where's the motion? Go down. For this one, actually, we break the coordinate system. We break the coordinate system from this side to this side. This one, we assume go up positive. But when it come down, we assume go down positive. Okay. So this one wrong. If go down positive, if you still assume go up, then your vector will be different here. Your VC here will be go down. Right? Okay, hold on. If I still assume go up positive, the rocket from B to C, if I still assume positive, go up, velocity VB 0, VC, where's the direction of velocity? Go down, right? So if I assume positive, go up, my VC will be negative something. My VC will be negative value. So this is the difference. If you use positive, negative, so on. So if you axis go down positive, so your VC will be positive. AC, here AC pull down, AG, AC, AC equal to G equal to negative 9.81. But if this one you assume go down positive, so AC equal to positive G will be 9.81.
Because the SP have not shell. Instead of shell. It's final position minus initial position. If up there we assume 0.
It's a final minus previous one. Final minus previous one. Huh? It's a delta S lah. It's a delta S. Yes, we'll assume B as an inertial for when it come back. No, final minus inertial delta S. This is a distance. What is the distance of C? 0, right? SB is 327. 327. This one SB. First point. This is second point. You take second point minus first point. No, this is second point minus first point. First point, second point. So you take second point minus first point. Yeah? How come you take first point minus second point? Yeah, it's a final is here. This one 327. Yeah. Correct. Your argument is correct lah. It depends on where you put lah. Your argument is correct. There are two angle. There are two angle. One is our reference point is here at O. Then something happened from here, B. Then back to C. Okay, our reference point here is 327. This is 0. Then if you are starting point from 327 to 0, then become 0 minus that one. Become you still take the second minus the first one. You don't confuse with the magnitude. You don't confuse with the magnitude. You are more interested in the location. Location. You are referred to reference here, not here. You're still solving as a means the second part, actually I'm solving my question from 0 to 327. So this one is a second location, first location. Yeah. Okay. You don't change your ruler. In dynamic, you don't change your ruler. Don't put your ruler flat like this. Don't flip. Means you fix at one reference, you stick there already. Then the location you refer to what is the previous one and the last one. Yeah. Okay. All right. The rest you read now. Okay. We have done with the continuous motion. Now we go into another section. I think we go a bit fast. So this one, we start to describe particles that move, stop, move, stop. Let's say this particle move, suddenly accelerate, then stop, then deaccelerate, start to slow down. You cannot describe this motion by the three equation there. These three equation only happen at certain incident. Here to here, you can only one of the three Newton equation. Here you need to you're looking at this time frame and this time frame. So you cannot use the one set of Newton equation to describe the here to here. Now we talk about erratic motion, means something happened throughout the time. Okay. So previously, continuous, we described the motion using position, velocity, and acceleration. But now we are looking at erratic motion. We cannot describe it properly. If we use equation, it becomes an average things. So we don't want that. So we use graph. We start to use graph to describe the motion. We start to introduce you five types of graph that you need to learn in chapter 1. First type, S versus T. Second type, V versus T. Third type, acceleration versus T plus another 2. Your x-axis become displacement or position with velocity and acceleration and displacement. So very high chances your test 1 will be this one or this one. Your test 1 will be either you seeing S versus T graph or V versus S graph. If this one come out in test 1, you won't see this one in final anymore. You will solve more easier question. It depend. I haven't set the question yet, so it depends. If you test 1, you see this one, final you will see this one. Okay. All right. Now we use 3 type of graph: ST, VT, AT graph. Okay. So you know about graph. Okay, before we move in, graph, you know you have a few type of graph. In general, right here. In general, y and x graph, you will have straight line. Give you y equal to mx plus c. Second type, quadratic graph. Quadratic graph give you y equal to ax squared plus bx plus c. So when a equal to more than positive value, it will be a smiling face. This is a smiling face. So if less, it will be a smiling face. If a less than 0 or negative, it become a sad face. Means you flip the side. Okay. The third one is polynomial graph. Axn plus bxn or something plus c. This polynomial can be power 3, power 4, power 5. Okay. So the graph will look something like that. Okay. Go home and review what are the form of the graph that you expected, because Sometimes you get v equal to 3t square plus 2. You need to know how to plot power 3 kind of graph. Or if you get 1 over or log, you get a log graph. Or what is the shape of the graph, for example. Okay. On the graph, you usually see gradient. What is gradient? Gradient is dy dx, right? This is y, this is x. Let's say I pull out a straight line. How to find gradient? M, this is y equal to mx plus c. How to find m? M is a gradient. M is delta y, delta x. So you take y, delta y divided by delta x, or y2 minus y1, x2 minus x1. This one you should know lah. This is 0.1, this is 0.2. This is gradient. Okay. Now, polynomial graph or quadratic graph, let's say I use a perfect quadratic graph. Maybe not this one, but maybe this one. Okay, so this one, how you find the gradient of this curve here? Also same. So you have y equal to one equation, maybe ax square plus bx plus c. How you find this gradient? Also dy dx. At this point, 0. When the line flat, dy dx 0. When you see this line flat, dy dx 0, your gradient becomes 0. Okay, these are the things that this is just a revision how to find gradient on the graph. Okay. Then you change ST to VT graph. I will show you how to do from here to here. But again, this is just to show you how to find the gradient. The gradient is dy dx again. So on the ST graph, the gradient is ds dt. Again, recall ds dt equal to velocity. VT graph, the gradient is dy dx, y and x. Dy dx, you get dv dt. dv dt is acceleration. So gradient on the ST graph is velocity. VT graph gradient is acceleration, and each point have different acceleration. For example, then you convert VT to AT. You can only see acceleration. Also, of course, here dA dt doesn't mean anything. Okay, dA dt, the rate of change of acceleration. It doesn't help you to solve anything. Okay, important is how we derive or how we build the graph. Okay, so every time you're given a statement like one object move from somewhere, what time, what is the velocity, then stop, and so on. You convert the information into graph. So ST graph, you draw S versus T. Let's say you have a graph, something like that. Point 1, T1, S1, something like that. This is just a Cartesian plane, Cartesian graph information. This is just a recap of that, right? Recap of that. Ignore this one. This one, you come back to this during final exam. At this moment, maybe you confused why this one become this one. Ignore this graph first. Right? At the moment, important is on this graph, S versus T, dy dx, what I get? ds dt is velocity at that particular point. This is velocity 1. If you do the s dt for point 1, you get velocity 1 for this point, 2 here, 3 here, 4 here, and so on. Yeah. VT graph, same. This one same. I already mentioned the gradient. AT also same. Ignore the shape of the line. Important is we look at the gradient. Gradient doesn't mean anything. Okay. But area under the graph, it means something. Area under the graph, it means something. So A versus T, if you integrate means area under the graph. You integrate. So A equal to dv dt, AT equal to dt, you integrate AT side, you integrate from here to here, this is AT graph, you integrate, you get the area under the graph. Area under the graph is velocity. Area the graph is velocity. Okay. So this is the integration sign, integration steps to convert AT back to VT. Okay, I give you a cheat code. First, you on your answer sheet, you write ST, VT, you draw this kind of graph. Then you draw same, you copy the same, you use the same ruler, you draw VT, then you draw the same, this one AT. You want to convert ST to VT, this direction, this direction. ST to VT, you do dy dx. Means you do integration. What I mean by integration? How many integration information you have earlier? What is the two equation? V equal to ds dt, A equal to dv dt. So if you want to convert ST to VT, you have information of S and T, you convert to velocity. ds dt, you get V. So you do differentiation to convert ST to VT. If you want to convert VT to AT, same. You take VT over AT information. This graph. Later I will show you one example. Then you will see these steps. If you want to reverse from AT to VT, you want to reverse from here, this direction, you do integration. dx integration. So how to do this one integration? You modify a little bit this equation. You move v dt, this one to here, v dt equal to ds, put in the integration sign. So you want to move from vt back to ds, you use this integration. Vt reverse to ds, you refer v and s. Vt ds, here to here. Then here, integrate a dt equal to v. So you convert at to v, you use this equation from this graph to this graph. This is a trick. You follow this sequence, you don't jump sequence. So you cannot jump from here to here. You want to jump from here to here, you need to do double differentiation. This one time, and then this one time. So you complete one graph by one graph. You don't go through too fast, don't jump fast. And then I will show you example of VS and AS later. This one cannot use this one because here don't have T here. These two graphs don't have time. These two graphs you need to use the A dv, A ds, V dv, this equation. To convert here to here, here to here. Okay, I'll show you example. This one just an illustration. All these are just saying what I draw on the whiteboard here. Okay. These are all the derivation steps. Okay, let's look at one tutorial question. This is how you convert ADS into this one, right? So again, same. You move down VS to VS to AS, you do integration. You work from AS to VS, you do integration, same. Okay. So means this one, this equation, if you convert, if you have differentiation, this one, you have differentiation, then it's from, so I'll show you example, more practical. All these are theory. Okay. The rest, okay, I'll show you this one. How you apply this erratic graph. So example 4, let's say your bicycle move in the straight road. Again, just still in the straight line. See this one as particles. See this one as particles. Described by the graph shown below. Construct VT graph from 0 to 30 seconds. So you are given this graph with all this time frame and the equation. This graph given. Okay, but sometimes we don't give you graph. We put this graph as the statement in the statement. So for example, it will tell you this bicycle move from 0 to 10, and the distance traveled is given in S1 equal to 0.3 t squared. After 10 seconds, the distance traveled by the bike changed to 60 minus 30. And the distance or the position reached by this bike is 150 at 30 seconds. Distance reached at 10 seconds is 30 meters. So you need to convert all this information into graph. Sometimes it do not give you, but most of the time will give you the graph. Okay. First steps to solve this kind of question. This is under chapter 1, erratic motion. You draw these three graphs first. You build this platform, this template. We call it template. Then you copy this one, the whole graph here. Okay, I start to show you how to do. Now, when you copy, what to copy first? You copy the time first. You copy the time first. So what time is given? 10. Right? You use your ruler to trace one line and write here. T equal to 10 seconds. Here also, T equal to 10 seconds. T equal to 10 seconds. Then you copy another time. Okay, you write T equal to 30 seconds. T equal to 30 seconds. T equal to 30 seconds. Of course, this dash line, you don't draw very hard one. This is just a guideline. That's just a guideline, so that you know what actually happened. Okay, then I copy the distance here, 30, 150, and there's a shape of the line here, s equal to 0.3 t squared. This one is another one is something like that. No, it's a straight line because y is in the form of y equal to mx plus c. Y equal to ms plus c. This one is a quadratic graph. Okay, this one is s equal to 60 minus 30. Okay, next steps. You do VT graph, right? VT graph, you do by section. You go from 0 to 10 first. 0 to 10 is this section. You go from here. You go from ST to VT. You use what? Integration. st to vt, you do use this information. V equal to ds dt. Okay. V equal to ds dt because you are moving from s to v. You're using integration. So you start in your answer, you write one section to another section, you write for 0, t from 0 to 10 seconds, look at the symbol here. I do not put a dash at the 10 there, because at 10 there is a transition point. It's a transition point. Yeah? So I put another one, t 10 equal to 10 to 30, this slot. Okay. Then I write the equation I know. S equal to 0.3 t squared. I know that my V equal to ds dt. So what is the velocity I get from this equation? So it becomes 0.6 t is my velocity equation. Yeah. So this one, you write this one, you do the V equal to ds dt, you do in differential equation equal to 0.6 t. This is linear equation, y equal to mx plus c. So it means this quadratic graph, it become straight line here. And it's positive, go up, m positive. So here, I just write here, just in case you forget, y equal to mx plus c. From the derivation, 0 to 10 is 0.6 t. And the equation will be v equal to 0.6 t. Write that on the graph. Do you know the value of this point? The value of v? You have the time here, right? So you use this equation, 0.6 multiplied 10. This one will be 6. Of course, you need to remember to write. You need to remember to write. Just 1 second, second, meter. Okay, then you do the same for the second session, second region. Second region, you have one equation, s equal to 60 minus 30. You do the same because you are converting from s to v. You write again, v equal to ds dt. So what is the answer for this one? 6. So 6 is the constant number. How to draw constant number on the graph? These are some of you don't know how to do. Lily, last few semester, they will show one student don't know how to do. He will draw something like this and then write 6 here. This is wrong. It's a straight line. You must straight line and then meet the 6 number here, then write v equal to 6 meter per second. This is the line equation. Okay, you get the idea. Once you know about this, you just follow accordingly. You can build the AT graph. Okay, if you understand this one, you can do for the AT graph. How to do AT graph? You have the equation here. Okay, you just differentiate one more time. Okay, okay, we complete the V graph first. So the VT graph should look something like this on the screen. Yeah. It should look something on the screen there. All the value must be clearly stated. Clearly stated. Okay. This is just extra information. Just show you that the answer is 6 if even you use a gradient equation. Okay. If you use a gradient equation, or ds means the change of position divided by time. if you want to use a very old understanding, then you get sticks also. Okay. Now, how we convert to v to t, same differentiation. Call out the at equal to break into the different time zone, 0 to 10, 10 to 30. Just need to be careful on the notation you write in your answer. For the first one is 0 with the dash there, and this one without, because it's a transition. Then only for the second one, you will see the equal sign here. Yeah. So for the first one, we already have a VT. We want to convert into AT. So write V equal to 0.6t. This one derived from the previous one. So then you write A equal to dV dt. Basically, you do differentiation of this one. Will become 0.6. Acceleration equal to 0.6 for the time 0 to 10 seconds. Again, this is a constant value. Constant value should look like straight line. Go here. Write 0.6. Then write A equal to 0.6 meter per second squared. You do the same for the second one. What is the second one? 0. Some of you also cannot do. You see this one, you add something there. So you integrate constant value, you get 0. How to draw 0? Your graph should draw something. There must be a pencil line or there's a line there. Draw something like that. Then you write A equal 0. So your graph looks something like this. Oops. Your graph will look something like this, and sometimes even you don't draw anything, I'll still give you correct because it's 0. Okay. Okay, let me show you how I mark the graph. Usually this question is easy to score, but also easy to lose mark. Axis with unit 1 mark. Okay, if you draw the axis, you draw this one, you get 1 mark with the correct label, axis, y-axis, x-axis. Second one, normally you'll see two slot. So lines equation, sometimes 1 to 2 marks, it depends. Right, I'll just put 2 marks. Lines with equation, lines with equation. Axis, okay. Axis, maybe I give you 2 marks. So graph will be 4 marks. Axis including the value here. The value for the important point there. But it must be written on the y-axis there. Sometimes students forget to write this value. Okay. Now for the graph alone, 3 graph, 12 marks already. The graph alone, if you draw something like this, graph alone, presentation, 12 marks. So one question, 25 marks. This graph already 12 out of 25. So there's 13 marks out of 25. Where is 13 marks? All this calculation. All this calculation. So it roughly, like the calculation will be 4 to 5 marks. It depends on the complexity. So for example, this one, no complexity. The one that maybe you get a quadratic graph and all this, that one will be more marks. Okay. So the calculation, 4 marks, 4 marks, 5 marks. For example, Okay. Okay. Okay, I'll show you one more example, then we call it a day. Another one. Another one, it gives you this statement. No graph. It gives you a car start from rest, travel along a straight line, such that it accelerates at a certain value for 10 seconds. Then it deaccelerates. Deaccelerate 2 meters per second. Deaccelerate means minus, negative. Negative. Draw VT-ST graph and determine the time needed to stop the car, how far the car is traveled. Basically, the question should be draw AT graph, AT, VT, ST graph. The question should be like that. Okay. We need to generate AT first because the question gives you acceleration. So acceleration, you start from here, AT. You want to do VT, you do integration steps. So this example is a reverse one. So you read this question, you draw this graph. You draw AT, put in the unit meter per second square, second. For the first 10 seconds, how many? 10. So write 10 here. Then after 10 seconds, deaccelerate 2 meters per second. You don't know the time. The question doesn't mention time. So what you do? Things that you don't know, you put as a letter. In this case, I put T-stop. It will show stop one. Deaccelerate means you press the brake pedals already. It will show stop at certain time. Now it's same. The question asks you, time needed to stop the car. So there will be a time you need to calculate to stop the car. So you need to draw this line and then put something you don't know, write as T stop or T something. Okay. So you add in one more line again. Deacceleration means negative. So sometimes student careless mistake also. He will draw this one here. Then he write 2, then wrong. One graph wrong, basically the rest also wrong already. Basically, one graph wrong, the 12 marks gone. 12 marks gone, the calculation also wrong. So basically it's 0 marks. Maybe I'll give you 2 marks for effort out of 25. So that the other marker, they see the marks, 2 marks, got attempt but wrong answer. Okay. So same procedure. You draw this template. You draw ST, VT, AT, but in this case, you start with AT. Right? You draw the line, the blue line here. Put in the time frame. In this case, it's 10 seconds and T-stop. Okay, now we want to draw this one. Same. Same. So here, you're looking at 0 to 10, 10 to T-stop. You draw the line first. So you should ready the template. The template. Remember the unit. Without unit, minus mark there. Without unit, minus mark. So if you draw VT without unit, you only score 1 marks. Okay, now we start to look at the first region. 0 to 10. You have value of 10. What is the definition of acceleration? A equal to dv dt. You move your dt to the left. Yeah. You move your dt to the left. You'll get integrate a dt equal to dv. Basically, you arrive at one equation equal to one equation. This one is v. Okay. Same, we look at one particular time. When we integrate, means we reverse the process from A to V, is under the graph, area under the graph. Area under the graph. So integrate AT equal to integrate dV. Okay. So again, split into two regions, 0 to 10, 10 to T stop. Again, if you don't know something, just put a letter there. So you put in here, important is the limit that you put. On the left-hand side, integrate A dt, you start from 0 to 10. The time is from 0 to 10. On the right-hand side, integrate V dV from 0 to 10 seconds. Okay, but again, don't write 10 here, because on the right-hand side here is velocity, not time. So what you do, you write velocity at 10 equal to 10 seconds. Don't write 10. Write 10 means velocity equal to 10. Because this right-hand side is velocity. Okay, the rest is substitution. Second also same. Second part also same for this part. Integrate from AT, integrate AT. Start from where? Start from 10. Careless mistake usually here. Your brain will tell you to write 0 here. Especially when you break the time. Most of the careless mistake I've seen is here. You will see write 0 here. Although you know when you answer, you know it's 10, but when you write in your answer, you write 0. Okay. 10 to T stop for the dt. Then this side is dv. Start from what? This is velocity, not time. So velocity at time equal to 10 seconds to velocity to T stop. Or you can just lazy, you write V stop. V stop. This one you can write V 10 seconds. You can write 10s there. As long as you know what you are doing. Okay, the rest substitution. Okay, the rest substitution. So we start with the 0 to 10. You substitute, you do integration. This one, constant value, A is a constant value, pull out. Basically, you are integrating 1 dt. 1 dt become this one. All right, 10 to 0. Then this one also 1 here. You get V and then VVO. You arrive at 1 equation. Okay. So you'll get, you substitute, you'll get 10t equal to V. You substitute value, you get 10t equal to V. Means from 0 to 10 seconds, this region here will give you what graph? Linear graph or straight line. Linear graph or straight line graph. Y equal to mx plus c. This one don't have c. C is 0. So you know that it starts from 0. Intersection is 0. Okay. So you know how to draw this one, right? This is go like that, not like that. Go like that. You draw a line, go up, mark a line here. What is the value here? You substitute 10 inside here. So velocity is 100 meters per second here. Yeah. Okay, so I write here. The line is straight line like that. It's just an interpretation of equation into graph form. Okay. Second one, I've done with the first part. Okay, so something wrong here. Okay, there is a okay, correction. Usually it should be written as this one. It should be not 10t. It should be a 10 minus a0 equals 0. It should be 10a equal to v. These are the careless mistakes. So when this kind of question come out in your assignment, don't just copy. You need to give the correct one. Okay, so these are the area where you will make careless mistakes. Okay, I highlight with the correction. So it should be 10a equal to v, not t. 10a equal to v. Sorry, 10 So yeah, 10a equal to v, correct. Y equal to ms plus c. This is y, this is x. Y equal to mx plus c. You're actually plotting v versus v versus t. I think wrong again. It should be correct. Correct. Okay. V equal to 10. Okay. Okay. Yeah. Okay. Right. So correction. This is correction on the notation now. Okay. Then you do the same for the next one. Same. So you integrate AT. You'll get A, you move to the outside, you get T. So T stop to 10. This will be the careless mistakes. You will write 0 here. It should follow the previous point. You substitute accordingly. You'll arrive at one equation. A, in this case, again, careless mistake here. You will forget to carry the negative sign. You write 2 here. This is deceleration. So -2. Continue, -2 here. Don't write 2. Because our brain was trained to give positive value always. And we assume always start from 0. Okay, so these are the things you do, you rearrange, you get that V stop or V equal to 2t plus 120. This is also a linear equation, however, with the negative gradient. Y equal to mx plus c, your m is negative. So what you do, you draw, not go up, but go down. Here to here, go down. Then of course you don't need to extend. You don't need to extend the tail of the second one. You don't need to give me 120 here. Don't need. We are more interested in the red line here. Okay. So you write the equation. So you write the equation. This equation is this one. V equal to -2t plus 120 right here. So from here, you can solve the t stop already, actually. When t stop, what is the velocity? 0. So only one unknown here. When this one 0, you have one unknown there. Solve the unknown, you get the time. So it's 60 seconds here. Yeah, it's 60 seconds. Don't your brain will try to trick you. Like some of you, you once you get this one, you will add 10 here. Then you write 70. Oh, you get 60? You can solve this equation. Can I? Okay. Don't go hand itchy, go and add 10 here. Is actually because you're using the correct boundary condition. You're using 10 as the time here. Yeah. I've seen previous semester. I think one student calculation perfect. When it comes to graph, he go and hand itchy, go and add the time here. 60, he calculates 60, but on the graph he will write 70. Not 70, 60. Okay, do the same for acceleration. Sorry, for S versus T. Okay, versus T, this one I think I give you as a homework. Homework. You have class, no class, right? No more class, right? Have class? No more. Okay, this one I go very fast. You can mark down the answer if you want. You do integration. Again, here this you just pull the equation of this one and this one, and then you do integration again. Okay, you do integration for 0 to 10. This line will convert to this equation. Because why there's a square here? Because your v is what? V is 10t. Yeah? Your v is 10t. So substitute 10t here. Your t, you integrate, become t squared divided by 2. Some careless mistakes also here. You will stop at here. You forget there's an equation here. You arrive one equation s equal to 5t squared. This is what? Quadratic equation with a positive a. It's a smiling graph. Smiling graph, how to draw? Where's the smiling graph? Like that. You need to know where you start the graph. It will be like that. Smiling graph, it will be like that. It will go through the 0 here lah. Smiling like that. Okay, smiling graph. But you don't need to draw the another half. Okay, smiling through the O. It's a square, so look like that. Don't here you solve for quadratic. Don't draw straight line. Okay, then you write the answer. Solve for the second half. Okay. Here you also can know the S already. Here is 10 seconds. Substitute 10 here. You'll get 500. Wait. Okay, I solve here, then I answer your question. Right, I go through the slides. At the end, for the second half, 10 to 60 seconds, because previous you already solved the 60 second already. So you have the time here already. Then you substitute. The second half is v equal to minus 2t plus 120. Substitute this one over here. Solve for the t integration. You arrive at one very lengthy quadratic equation. Okay, this one is negative. Negative. This is negative quadratic equation, so it's a set phase. Set phase like that. Then write equation there. Remember to calculate the stopping point on the graph. This one you substitute 60 seconds in this equation, you get 3000. Okay, so we stop here. See you next week. Yes. And